Today we are going to present to you SOCAR Türkiye's rotating equipment reliability strategy together with my colleague Emre. Before going any further, I want to introduce myself. My name is Efkan Ölçer. I am the rotating equipment maintenance manager in SOCAR Türkiye. I have been working in SOCAR for 7 years. I have total 15 years in oil and gas field. And my colleague Emre will introduce himself.
Good day, everyone. Welcome to our session. And my name is Emre Eroğlu, and I am working as a predictive maintenance lead engineer at SOCAR. I have been working on predictive systems since 2019, I think, and I hope we will give you good insight about our experience. Thank you.
Yeah, I will briefly give some information about SOCAR Türkiye because my colleagues already give more details than me. It is the one and the only refinery and petrochemical complex in Turkey. SOCAR has various business in our country, but the refinery and petrochemical business unit is located in İzmir, Aliağa, Turkey. Here you can see Star Refinery, Petrochemical, Petkim Petrochemical, SOCAR Terminal, Storage, and Wind Power Plant. We are responsible from the rotating equipment maintenance in both refinery and petrochemical, together with my team. So here is our presentation outline. Before going any further with the predictive maintenance activities detailedly, I would like to present you our overall rotating equipment maintenance strategy. Then I will describe how we study the RCM together with GE Vernova's APM module. And then my colleague Emre will describe the details. The actions comes from RCM, which are vibration and lubrication activities, switchover policy, and preservation, and the usage and the benefits of the smart signal. So we are servicing around 4,000 rotating equipments in our refinery and petrochemical complex. And we are dealing with several challenges and have some KPIs to monitor our performance. You can see some of names here. We are several types of rotating equipments installed in our facilities, especially in polymeric plants. There are several types of different equipments. And also, to optimize the workforce necessity, we have different strategy for turnaround in petrochemical plant and refinery. So, the cycles are every 5 years, but because we optimize the durations, every 2.5 years, we performed a major turnaround, one in petrochemical, one in refinery. The last one is October 2024 in refinery, which was the first turnaround after commissioning. And we performed major overhauls on all major rotating equipments with flawless startup. And also we are dealing with budget planning, availability of the equipments, backlog management, and meantime between failures for pumps. And RCM is, reliability standard maintenance is, one of our strategical tools to optimize our effort and get acceptable reliability levels. So here you can see a brief visualization of RCM. First of all, you should do your study for identification of equipment criticality levels. When you identify equipment criticality levels, you can decide the care level of your equipment. And then it should be cost effective, and you should identify your failure modes. Because RCM studies are time-consuming activities and includes several discipline participants, the experience levels of the participants may affect the result of the study. That's why we try to make it standard just to identify the care levels. Let's say basic care, standard care, and optimized care, which enables us to be a cost-effective, not over-maintained, but together with have desirable level of reliability. And the outcomes of RCM is corrective maintenance, preventive maintenance, and predictive maintenance. We will go details for predictive maintenance, but before going further, I have to explain briefly corrective maintenance. Even if you perform studies, implement newer technologies, it is inevitable to have some breakdown maintenance on site. So we still have breakdown maintenance. And also, according to criticality level of our equipment, it is an option to select run to failure. So still we have corrective maintenance here. And also we have time-based preventive maintenance activities. And those comes from several sources, but I want to highlight switchover and preservation here. We have a robust switchover policy, and we use a software to follow it. My colleague will give the details. It is because we want to have a reliable, redundant equipment in hand. That's why we are following the switchover policy is followed strictly by the operations. And also, if there is a violation, we are asking them to implement preservation on site to keep the equipment reliable. And also we have some warehouse spares, and we implement those preservation activities also for the warehouse spares. And the last one, predictive maintenance. We have a robust lube oil management. We have site tours, periodic site tours, lube oil sampling, lube oil replacement activities, and oil flushing, which is standard for our team after an overhaul, after a maintenance. Also, we have online and offline vibration monitoring. Offline vibration monitoring is manually getting vibration data on site by site tours, and online is the sensors attached to the equipment. We have few other digital tools implemented, but for very critical process equipments in refinery, because refinery is newer, we have smart signal implemented on 13 of very high critical equipment, and we will define the details. As you can see, evaluating some failures and criticality scores, we have a guideline: basic care, standard care, and optimized care. Let me give you an example what those care levels mean. Let's consider a highly critical process gas compressor. The basic care is operator round. Operator see, visually inspect the equipment, is anything abnormal exist. Standard care is the offline vibration monitoring, taking vibration data manually from the lube oil pump to ensure its condition. The optimized maintenance is taking lube oil samples quarterly from the lube oil tank or lube oil line, the proper location, or implement such a new technology as smart signal or other necessary activity type. So we are trying to optimize our maintenance effort to get acceptable reliability levels. I want to briefly show you some figures. This is pump MTBF value for petrochemical. Petrochemical plant is 40 years old. This is refinery MTBF for pumps, which is higher as expected. But this was around 35 years ago. So now we have 70, and it is getting higher. By using these predictive maintenance activities, we are increasing our performance really. And it also affects our budget, backlog, and our daily routine, problems. And this page is our RCM study page on APM. I will not give details here. We put all the data here. The criticality study results stored in APM. We identify failure modes, and then we decide which activity should be done as a recommendation and put inside the software. Then the output of this software goes through the maintenance planning department as a recommendation, not actionable item on SAP or other CMMS module. We are using SAP. And then they are, together with rotating equipment maintenance people, identify which kind of site activity should be put into SAP to cover the recommendation and eliminate the risk. Not completely, but extend the probability of that failure exist on site. So, as a result of the RCM study, we put some barriers and we achieve some actionable items on SAP, and site maintenance team execute on site and prepare reports, put the details in SAP. So together with SAP and APM, we have too many data for future use, let's say, to identify which equipment should be maintained during turnaround or which activity should be done to prevent unplanned shutdown. Here is end of my section, and I hand it over to my colleague.
Switch order. Yes, I will deep dive our topic actually. Let me begin with our vibration practice in SOCAR. We have two major practice for vibration actually. One of them offline vibration measurement and others online vibration measurement. And for offline vibration measurement, we have 10 portable devices in the field, and we collect our data from the field manually. Our technician team go into the field and take all measurements monthly based. We have a monthly based rounds for that measurement, and we have 2,870 measurement number of equipment in the field, and of course we have a much more equipment in the field, approximately 4,000. So that means our measurement point comes from criticalities and RCMs, and we have 27 locations at Peninsula. And in 2024, we completed 18,260 measurements in 1 year. And from that measurement, we opened 406 notification. From that, according to that notification, 334 action taken. For online vibration sites, we have a lot of fixed proximity and accelerometer sensor in refinery and petchem. And of course, that fixed sensors working like a protection system in DCS, but we are able to take all vibration data to our vibration service with our portable device. So we can correlate all vibration data in our service. In addition to that, we are able to upload all pressure, flow, temperature data to TrendMiner software. So we can easily evaluate our root cause analysis with that correlation. And last of this slide, we are working on a project in this year. Our purpose is upload all runs data to Asset Health Manager in this year. Moving on, the next item is oil management practice. Our lubrication tasks are divided into two main categories, one of them preventive and others predictive actions. For preventive actions, our lubrication teams have a daily based run. So our team go into the fields daily based and control all oil level and oil condition daily based. And after that control, if detect any problem, they open notification and change oil, or after the control, they send our sample, our laboratory for full analysis. And in 2024, we complete 83,585 rounds in the field. And in 2024, we have a turnaround in Star Refinery, and we complete 9 equipment full flushing in oil skid. It's a very huge job for our team, actually, in a short range of time. In a predictive side of our jobs in lubrication practice, our samples are regularly taken from the designated equipment and analyzed. In 2024, again, we completed 540 oil analyses. From that analysis, we opened 125 notification. That means actually our team prevent 125 possible failure in the field.
I have to add one point here.
Yeah.
The lube oil management is an underestimated activity on industry. But I can assure you, we found something on bearing housing which is not oil. And there is a dedicated team for lube oil management in our facility, just to ensure that a good condition oil exists in the equipment.
In this slide, I can explain how we use the policy in the field. For that policy, we create about to control all seal pot oil level and oil pressure in the field. That policy take data from the field online, and if detect any problem in the pressure, create notification to our oil technician team, and our oil technician team go into the field and take an action. Before that policy, our technician team doing that job in their rounds. Right now, that means we transform our preventive activities to predictive activities with that policy, actually. So it's a very useful policy for our technician team. And let me explain switchover policy for rotating equipment. We have a policy about it in different software, and the primary objective of the switchover policy is ensure the reliability of the equipment. As you know, a prolonged downtime of the equipment result in damage into mechanism of the equipment. So we want to create some system to collect the data, and if the equipment don't stop or run in their program, that system notify us with a mail. In addition to this system, as I mentioned before, we have a monthly vibration tour, and we create a report monthly based and send to our related team. And as you know in here, if we cannot take a measurement from the field, we highlight it in red in our report. After that, our technician go into that policy and open instance about that equipment. After that, the policy track our data online, and if equipment run or stop, the policy sent a mail to our technician team, and our technician team go into the field and take a measurement with that policy. So we ensure the switchover policy with APM software policy.
I also at one point here, maintenance people can understand sometimes operators start to blame both equipments failed at the same time. But we have redundancy, it shouldn't be. When we check the condition of the equipment before we implement such softwares and keep tracking of the conditions, we found that one is running for years, months, the other one stands still for a long period of time, and it is not functional because keeping standstill too much time. Now we are following by using this software just to ensure we don't have an emergent work order.
Another factor that I would like to cover is smart signal and our rotating equipment strategy relationship. Actually, you have a lot of knowledge about how the smart signal works. In 3 days, we have a lot of session about it. So, in a summary, we get some advisory alarm, and after that advisory alarm, we have a time for investigation with the system. That is our smart signal progress on SOCAR. We started the POC in 2021. After the POC, we did some valuation meetings and create a report about the valuation. In that report, we should have decided how to calculate the value of the system. So we made an assumption about it, and we did some acceptance based on the risk in FMEA. So if the system mitigates our risk in the FMEA, we accept that valuable case, this action. With this method, we calculate value, and after that, we decide to expand our project with 8 equipment, and totally right now, we are using 13 equipment in smart signal. And it is our 3 years summary, actually. We use the smart signal in 13 equipments in 3 locations, and with risk mitigation method, we calculate $1.4 million total possible earnings. That possible earning phrase is very important in here. And in the system, 1,665 alert occurring. From that alert, our team and GE team evaluate the alarm and open 89 case. According to this case, our team had 70 meetings totally in the 3 years. And last of my presentation, I would like to show 3 examples about smart signal. First case about our screw compressor. Our advisory alarms say that our vibration level high in that screw compressor. In that case, we saw that our vibration level high, and our team go into the field, our engineer and technician team, justify the value. After that, our production team and engineers evaluate the issue, and we found our screw compressor capacity and our vibration level is correlated. When the capacity is low, our vibration level is high. So our production team did some adjustment about our capacity, and our value is normalized. Second example about our centrifugal compressor cooling water system. That cooling water system is have one temperature control valve. That control valve is fluctuated after turnaround. You can see in here. And we found that some calibration problem in the field, and our instrument team go into field and take action about it, and after that our value is normalized. Actually, it's a very basic case, but very effective because we cannot find that fluctuation without that system, because it is under our alarm limit. And last example about our Lube oil sensor. Our Lube oil rundown tank sensor rapidly rising to and reach 100%, after rapidly decrease and reach 0% after normalize. We found some problem in the field, and our instrument team go into the field and check the calibration, and yes, they found some calibration problem in the field. After the calibration, our value is normalized again. And again, it's a good case for us because we cannot find that fluctuation without the smart signal. Yes, it is all of my explain, and I would like to give last word to Mr. Efkan.
Thank you for joining us and listen our presentation. I can say as a conclusion, this is a journey for rotating equipment reliability. We started from strategy propagation, and we study our strategy, get the output, implement on site, verify their effectiveness. Now we are in a phase that put that output into GE APM with the policies and follow with that APM structure. So we are in a phase that moving into APM. Maybe next year you will see a different presentation. Thank you.